I want to finish this simulation just by making sure we understand what this number indicates. So this came from my sample of 20, but the reality is it's just one sample average from many sample average I could have derived. So let me calculate the standard deviation of this sampling distribution. So it's going to be the old standard deviation divided by the square root of the sample size, which is 20. And I get a standard deviation of 3.57. So in other words, well, the old standard deviation was 16. This one, consisting of all passable averages of 20 numbers, has a standard deviation of 3.57. Okay, now let's find this under a normal curve. Since this one was normal, this one's approximately normal as well. So I'm going to come over here and I'm going to use GeoGebra. So I'm going to click on here and bring this up. So right now, that's a normal distribution with a mean of 266. Standard deviation is 16, but that's not what we have here. I have a standard deviation of 3.5, and again, I'm going to go 777. Okay, that's good enough. And now this shows us our new normal model, but really what's changed is the numbers at the bottom. Here's 266, the center, and what do we get? 278. Wow, 278 is okay. So that's very unusual. I mean, you can see that's not in a common region. So our chances of coming up with a sample this high or even higher, well, let's just take a look here. What do we got here? Infinity. 278.12. Yeah, there it is, 278.12. The chance of coming up with that average is 4 times out of 10,000 attempts. Yeah, wow, that's very unusual. We're starting to question, did I enter something wrong when I did the simulation? We'll check in a second. But let's consider for a second p-hat. Now that I'm kind of looking at this for the first time, I'm really considering what the numbers imply. If I look at 266, this is the halfway point. So I would expect half of my points to be greater than 266 and half to be less than 266. But my p-hat value said that, as a matter of fact, I calculated something different with my p-hat value. I calculated how often would I get 275 or more. Now I'm going to look at this curve again. 275, okay, boy. Here's about where, oh no, 275, sorry, 274. Yikes, so I got 65% of my values were bigger than 275. No wonder the average is so high. Again, I'm questioning if I entered something wrong into the random number generator. But this is very unusual. But anyway, that's not what I was after. I was just trying to show you where this number belongs out of all the possible averages that we could have generated. We just got to happen to be a very, very unusual value. Now I'm curious, what about p-hat? So let me come over here and calculate the standard deviation of p-hat for this situation, which is which I need to now determine what the chance of success is. Okay, I'm going to cheat a little bit. I'm going to use GeoGebra. So the chance of getting one number to be 275 or more, so the chance of success, one is 28.69. So the probability of success, if I remember that correctly, I need to go back. I don't think that's correct. 28.69. So that was my probability of success. How unusual is that compared to this? So let me again, I'm going to just cheat a little bit here and just use GeoGebra. I'm going to first calculate standard deviations, which is what I need. The standard deviation of this situation is the following. Square root of success, 0.2869, times failure, divided by 20 times, sorry, 20. My sample size is 20, hit return, and that's my standard deviation for this situation where P is 0.28 and N is equal to 20. Okay, now where does that lie? Well, let's see, do I have, can I use the central limit theorem here, CLT? It's N times P greater than 10. I mean, I can see no. The answer is not going to be no to that. No. Of course I have numbers in it. Let's understand that. So 20 times. Nope, can't do the central limit theorem. So this is kind of be sort of a binomial type situation. And what does 0.65 revert to if I'm just thinking of binomial? Let me just, instead of taking an average, let me take the sum here instead. So 13, I got 13 out of the 20. How unusual is getting 13 out of the 20, or is something more extreme? Notice I was expecting only 5.7 successes. That's what this is, N times P. But I got 13 successes. And that's, well, I mean, I could see that. That's way out of the ballpark. That's not even close. So something went wrong. Something went horribly wrong. But that's what statistics does. Either something went horribly wrong or we just got unlucky. Which one is it? Well, we're going to find out in a second. Binomial, what else? I got 20. Chance of success is not this. It is 0.2869. Oh, yeah, that's good enough. 7 maybe. Maybe there's one like that. And what is it that I got? I want, let's say, 13. 13 or more. How unusual is 13 or more? 13 or more. Yep. Yeah, the chance of this happening is 0.0008. In other words, 13 or more is what I got, and you can see that 5 is what we were expecting. I got something huge. This is way unusual. So I must have entered something wrong, or we just got horribly unlucky. Let's just check on data analysis again and random number generator. What did I enter? Mean, standard deviation, 20, normal, random seed. Wow, well, that ends our video because I'm going to buy myself a lottery ticket. This was a very, very unusual result, but I don't see anything wrong. It's just that I got lucky. Wow, I'll be back.